Good afternoon, good morning, and good evening, depending on the time you're watching this video. You're welcome again to VINDAL'S concept, and this is a follow-up. You're welcome to VINDAL'S concept, and this is a follow-up to the video that you watched on Projectile. If you have not watched the video, please go back to the video I did on Projectile, which is called the best explanation on Projectile, and I'm very sure you're going to enjoy it. But if you have watched the Projectile, thank you for follow-up. Thank you for returning to watch again. But I'm going to tell you that I'm not going to disappoint you. But on this time, I am going to take you up for us to solve problems on the projectile based on the principles we learned in the first lesson. You're welcome. Remember that this question is not limited to Waec students, not Neco students, Igcse students, and all exams. So I'm going to include all exams. Okay, he said a batter hit a baseball. So you carry something, hit a baseball. So when you hit a baseball, now with the speed of 37 meters per second, okay, so that it leaves the ball at speed of 37 meters per second at an angle of 53.1, take G as 9 points. So take G as 9.8 seconds. He said find the position, magnitude, and the duration of its velocity at time 2 seconds. So what you have to understand is that the position means the height at a particular time. And then the magnitude is just the value, the size of that velocity at that time. So magnitude is not anything. It's just what is the value of the height. That is what they're talking about. The duration of its velocity at this point. So at that time, 2 seconds, what is the velocity at that time? And what is the position? When we're talking about position, we're talking about the height so far. And then number 2, he said find the time when the ball reached the highest point and find the highest and the height at that point. So at what time did you reach the highest point? Because when you reach it here, it falls down. So at what time did you reach here? And then what is the value of that point of the height at that time? Then the last thing is find the horizontal range. Horizontal range you're talking about is from the beginning till the end where it hits the ground. So I am going to give you this video for you to watch. Now look at the video. If you check the video, you see that the same angle, just that I'm making my own video the angle to be 53. I'm not making it to 1 decimal place. So if you check the video, what do you see? Let's check the video. So amongst the 3 velocities that a projectile motion is concerned with, this hand pointing at the upper arrow is the vertical component of the speed. While this one pointing sideways is the horizontal component of the speed, which does not change at all. It doesn't change throughout the motion. While this one, the slant one, the blue arrow, is pointing in that direction, which is called the resultant velocity or the speed at a particular time. See what happens on this component of the speed. You see what is going on. The vertical component is reducing in value. The horizontal component is the same throughout, while the instantaneous speed, or what we call the speed at a particular given time, is going to be reducing because of the vertical component is reducing. Now, at the end, you see when it gets to a vertical height, you see is already, the vertical component is almost reducing. When it gets to the maximum height, it becomes 0. You see? Then only the vertical component will be 0, but a horizontal component will remain the same. But when it now starts falling down, the same thing continues. It will be increasing until the projectile hits the projectile plane again as it is going now. Look at that one. The velocity of that blue arrow at that point when it hits the ground is what we mean by the landing velocity or the resultant velocity. However, what I want you to know is simple, that at every point, the value of this resultant velocity or instantaneous speed or instantaneous velocity is changing at every point. Then also, let me just say this for emphasis. So remember, so as the body moves like this is the maximum height. So let's assume this is the time where t, let's say t is 2 seconds. Assuming I am doing this with respect to time. So let me say that this is 2 seconds. At this time, what will be the height? Assuming I'm measuring this one in meters. So I'm saying meter against time. So at this point, what is the height? From here to here. That means from here to here. What is the height? At this time, 2 seconds. So remember what I said before. At this time, there is going to be a vertical component, and then there is going to be a horizontal component, Vx, and there is going to be a velocity. So if you look at this very well, you see that this vertical component, the one going up, which is changing, and then this is the speed at that instant of 2 seconds. At this instant of 2 seconds, what is the vertical component of the velocity? What is the speed at that point, which is called the instantaneous velocity, or like I told you in my last video, I would like to call it the resultant speed. So what is the speed at vertical component of the speed at this time? What is the resultant speed at this time, 2 seconds? Because this one, which is the horizontal component, does not change. Now watch the video again for you to see how this one and this one are changing. Now you see the way they are changing, keep on changing. When you reach the maximum height, the only thing you are going to see is Vx. So Vy became 0 and U became 0. So they are not part of it. So they don't care. V is the only one that there is no one. They don't exist. This is the only one that exists at the maximum height. Now, finally, please don't cram the formula. Don't cram the formula. Just be patient and watch this video to the end. You will see how important it is for you to master what happens here. Just sit back, relax. I am going to run it through. Remember to share, like, and comment is very, very important. I am here for you. My intention is to give you the best experience on this topic. What can't you do? What can't you do? Nothing is possible. I beg, I'm not a musician. Let's get over this problem. Now, okay, I want to start solving. I have drawn this based on what I was saying. I want to find the position. The position talks about the height. So the position talks about the height. That means the position talks about if this is 2 seconds. After 2 seconds, what height? Because the body was moving this way. If it is at this point, we may say is 1 second. This is 1 second at this height. You can see the height. The height is not that much. Then if it goes to, then it goes this place. H2, that is after 2 seconds. If it gets to this point, maybe 3 seconds. H3. So what do you notice? You are noticing that the height is increasing with increase in time. That means height is a function of time. Now, which of these equations of motion that deals with height as a function of time? It is h equal to u y t minus or plus half g t squared. So you see, this is constant and height is a function of time and speed. So the speed, the speed at which the body is moving is determined by the, I mean, yes, the speed at which the body is moving is also considered with time and then the maximum height. So in this case, we are going to use this formula to find the position. Now, but remember, the uy at this place, I'll go to call it uy1. This uy, or I can even say vy, that is the vertical component at 1 second, I will call it uy1. So if you go to this place, this u will now be uy at 2 seconds. If you go to this place, it's going to be uy after 3 seconds. So this value is changing. This value of the speed is changing with change in time. And that formula, which is changing v, let me call it v, is saying the same thing, v or u, they are all the same thing. Depends on the concept you are dealing with. But now, what is that formula that deals with the fact that v is changing with change in time? It's simple. Vy is going to be equal to uy plus or minus gt. All right? But then, if u, the angle is considered, we're going to say vy is equal to u sine theta minus dt. So you see, what are we talking about? It's not about cramming the formula. If you cram the formula, you can find it at maximum height at the end at this point, but you may not be able to find it at different positions. This question is not really a Waec Neco kind of question. It's more of IDCS and its technicality. So that is why I don't want you to cram the formula. Just understand that V is changing. Now, how does that happen? See, at this point, we have this Vy, we have this side, then we have this. At this point, we have this y, we have this horizontal component, and we have this. So the speed is changing at every point. Now, I've told you, so it's changing, the height is changing because of time for this formula, and the speed is changing because of time in this formula. Now, so after 2 seconds, let me call this place 2 seconds. So this is 2 seconds. Now, how am I going to find, because at these 2 seconds, few things happen. After 2 seconds, we have Vy, which is the vertical component of the velocity. And then at this same point, we have horizontal component, which is Vx. And at this same point, we have this resultant velocity, which is called instantaneous speed or resultant speed at a point 2 seconds. Now, how do I find Vy, which is, yes, because I cannot find the direction without finding Vy. Also, before that, let me tell you that when we're talking about direction or direction means angle in maths. When you talk about direction, you're talking about theta. What angle did it make at that point? That's what you're looking for. And that is the direction. Then the next thing is, and its velocity. Its velocity at that point is this u. That u is going to be Vy squared plus u vx square is the velocity we are looking at. Then so remember that means then the position is talking about height at 2 seconds. So you see, these are the things. Now let's start. I'm going to start without wasting much of our time. I'm going to start by finding the Vy. So at this point, what is my Vy? Vy is given as this: u sine theta minus dt. So so what is Vy? So according to this question now, Vy at Vy. So there are two stages for me to be able to find at this point. 2 seconds. So it's going to be that this is the initial speed and this is the final speed. Because for anything you are solving, you start from a particular starting point and to the point you're looking. So I'm looking for V at this point. I'm looking for V after 2 seconds. After 2 seconds. V after 2 seconds is going to be Vy is equal to the U angle is initial angle, which is U, which is 37 sine 53.1 minus G is 9.8 times. What is the time? I'm writing 2 seconds after 2 seconds. So Vy is going to be given as 37 sine 53.1. So this is 29.6 minus 9 times 9.8 times 2 is 19.6. So Vy is meters per second. This is Vy. So this is 10 meters per second. Let me find Vx. Vx is u cos theta, which does not change. So which does not change. So I'm going to say this is u is 37 cos 53.1 degrees, 53.1 degrees. So I'm going to say 37 cos 53.1. So Vx is 22.2 meters per second. So the next thing I'm going to find is find u. Whatever I find u is going to be this velocity that they say I should find. So u is going to be the instantaneous velocity at 2 seconds is going to be this: Vy squared plus Vx squared. And that is Vy is 10 squared plus 22.2 all squared. So u at 2 seconds, the speed after 2 seconds is going to be, this is 100 to 2.2 square plus 100. So instantaneous speed is going to be 592.84, which is going to be square root of 592.84 is going to be 24.3 meters per second. So at this point, the speed here is 22.2 meters. How do I find the direction? The direction means, that is why I told you that this is resultant. This is the resultant velocity. And you are going to treat it as resultant velocity according to the principle of parallelogram law of vectors. Go and learn parallelogram law of vectors. So in that case, this is the angle theta, which I don't know. On this vertical component is 10 meter per second. On the horizontal component is 22.2. So this u, the direction of this u is going to be, with the horizontal, is going to be opposite over adjacent. Tan theta is going to be, opposite is 10 over adjacent, which is 22.2. So theta is arctan of 10 over 22. 10 divided by 22.2 of 0.5, 0.45. So theta is going to be, so or you simply put tan inverse, tan inverse 0.545, which is 24.2 degrees. So the direction at Vy is the vertical component of the velocity after 2 seconds, and the horizontal component of the velocity after 2 seconds is 22.2 meters per second. The instantaneous speed, that is the speed after 2 seconds, is called, or the resultant speed is called the instantaneous speed, which is 24.3 meters per second. Now, and the direction, which is the angle, the direction is 24.2 degrees. So that is what this question is all about for number 1. Now we are going to solve for number 2. Please, if there is anything you don't understand, try to ask questions and also subscribe and like. But understanding this very well, you need to watch my previous video. You need to watch my previous video. That will help very, very much.